Hello, in this video we're going to be looking at the aggregate expenditures model. This is a model that is related to aggregate demand and it helps us find the equilibrium in an economy. When the economy is in an equilibrium, we would say that total expenditures equal total production. This brings us back to that circular flow model of the economy where businesses and households have money and resources flowing back and forth. So we would say our economy is in an equilibrium where the total amount of stuff produced is equal to the total amount of stuff purchased. The economy would be in a disequilibrium when expenditures are higher or lower than the level of production. So basically where they don't match. People purchase more stuff that was produced or they purchase less stuff than what was produced. We'd say the economy is in disequilibrium. When the market is in a disequilibrium, businesses are going to adjust production and employment levels until they get back to that point where expenditures equal production. So if expenditures were lower than expected, less than production, that's a signal to businesses that they've overproduced. They wrongly predicted how much their customers were going to be shopping. And so they're going to produce less stuff in the next period, so next month or next year. And they're going to have lower levels of employment because if they're producing less stuff, they don't need as many workers. Similarly, if expenditures were higher than production, this is going to lead to a shortage or more customers showing up than were expected. This is a signal to businesses they can produce more stuff. They're going to increase production, they're going to increase employment. So in this model, we're going to be using real GDP. It's going to be a function of consumption. So the slope of our line is going to be determined by consumption, how much consumers are going to spend. This is going to be related to their level of income. And then we're going to see other components such as investment, net exports, and government spending are going to shift this curve upwards. And it's not that investment or government spending, net exports have nothing to do with a function. They're not always constant. But in this particular model, we're saying real GDP changes based on consumption, whereas government spending is autonomous. It was something that was determined in a prior period or another model. And so aggregate expenditures model just takes the government spending level that was determined in some other process and plugs in a constant number here. So here is our aggregate expenditure function or curve. We're just going to start with consumption because that's the part of this equation that's making our line upward sloped. So here we can see on this graph, on our y-axis, we have consumption per period, so the dollar value of consumption or expenditures. And down here, we've got disposable personal income per period, which is also related to real GDP. And so what we want to know is how much money are consumers going to spend? It's related to their disposable income, right? How much money did you bring in is going to determine how much money you're going to spend. It also has to do with basic needs. So sometimes, regardless of what your income is, you have certain spending needs that have to happen. Relative wealth, so things that you own of value. This is independent of your income, but it's also going to affect how much you spend now. And then what about saving? So in this model, we do actually have saving come into play. I know in some of our earlier chapters, we ignored saving. We said everything's being spent. But in this case, saving actually does play a role, and it will help us figure out what that equilibrium real GDP is going to be. We can have a negative saving rate or dis-saving. This is where our consumers are spending more than their total income. Saving could be zero. This is where our consumers are spending all of their income. There's no saving. Or it can be positive. This is when consumers are spending less of their disposable income. So if we're looking at this line over here, we could see at the top there's a table telling you what those points are. So here we've got point A. This is where the income of our consumers is $0. They have zero income, but they still have $300 of spending. So presumably this is for some basic needs that must be paid for regardless of whether or not any income happens. We're going to see how this is not going to be an equilibrium point. We're not going to be at point where all of our consumers have zero income and they're still spending money. But what this is telling us is that $300 is the autonomous level of spending. This is the basic amount that has to be spent no matter what, and then all of the other increases in spending have to do with the change in income. So we have some autonomous spending, and then we have some spending that is affected by the level of income. And so what we're going to do is we're going to look at how changes in income and changes in spending affect this line, and it's going to help us develop this model of our marginal propensity to consume and our marginal propensity to save, or our MPC and MPS. Now we're looking at marginal. So marginal analysis is going to be anytime we get a little bit extra of something. So in this case, when we go from point A to point B, we are having $500 of extra income. We went from 0 to 500. And our spending or consumption went from 300 to 700. So our extra spending is $400. So we'll be looking in a later video, we're going to be talking about the multiplier, so how money multiplies in the economy, and it's going to be related to how much of this income consumers spend. We are going to have a constant slope, meaning we're going to be having a straight line here, and that means that we're going to have a constant change in consumption and saving. So every time, on this line in particular, every time we have an increase of $500 of income, we're going to see that our consumers are going to spend $400 of it. And since this function has saving, that means that our saving is going to be that extra. It's going to be 100. So every time our consumers in this economy get an extra $500 in disposable income, they're going to spend $400 of it, and they're going to save $100. This proportion is going to be important later when we look at the GDP multiplier again. So marginal just means extra. Propensity has to do with like the quickness to consumer save. So it's like how much extra are you spending, how much extra are you saving? So it's going to be the proportion of new disposable income that is spent or saved. In this case, we're going to get a slope. Positive slope, because we have an increase in income and an increase in spending. Now we see at point A, we've got some negative saving, right, or dissaving. We're spending $300 more than what we earned. Point D, we've got zero saving. And this is talking about total, not extra, okay? Because at point D, we are earning $1,500, we are spending $1,500. At point E, we've got positive saving because we are earning $2,000 and we're spending $1,900. So even though we started out negative, over time, we're going to get to zero, and then we're going to get to some positive level because we're increasing our spending, but not as much as our income increases. And so eventually it catches up. Now, we're going to see later we're going to add investment, government spending, net exports to this, and it's just going to shift the line up because we're going to say that everything that is determined outside of this model is going to be an autonomous expenditure. So we're going to say, for instance, government spending is not determined by the level of people's income. So government spending this year is determined by various legal requirements, legislation that's been previously passed. There's different requirements. So like if there's a recession, unemployment payments go up. And so that's going to increase how much money the government is spending. And so we're going to say government spending is some dollar amount that's autonomous because it's determined by something else. And in this model, we have some portion of consumption that's considered induced aggregate expenditure, meaning it's affected by the level of income. So this model that we have here, we have consumption is caused by disposable income. And we start out with some level here of 300. This is autonomous spending, but then the rest of it, all of those increases are caused by this change in disposable income. And so we're going to expand our model where instead of just having consumption on this vertical axis, it's going to be all expenditures. Or aggregate expenditures, right? Because aggregate just means everything together. And down here, we're going to have disposable personal income. But once we expand this and we add our other components, this is going to equal total production or total real GDP down at the bottom. And we can do that because of our circular flow model, because GDP can measure income or it can measure expenditures. So autonomous aggregate expenditures don't change with the level of real GDP. They don't change with that level of income. We're going to have autonomous government spending, autonomous investment. We're going to have some small portion of autonomous consumption and also net exports. And so the only thing in this model, this particular graph, that's going to change with the level of real GDP is going to be consumption. And this is going to be determined by that marginal propensity to consume or the marginal propensity to save. So we're going to assume that our consumers have some sort of consistent way of spending and saving. So what we're going to see is that when consumption goes up or down, it's going to shift this whole line vertically up or down. If consumers spend, more income or they have higher autonomous expenditures, it's going to shift that line up. If they reduce their autonomous expenditures, it's going to shift that line down. Here it's broken down into 3 different graphs. So we have $300 in autonomous consumption, which means that amount is going to be spent no matter what. Then we have this upward sloping curve where consumption is equal to 80% of income, or 0.8y. Here you're going to get this upward sloping line where consumption is always going to be 80%. So if you have $500 in income, you're going to have $400 in spending. If you have $1,000 in income, then you're going to have $800 in spending. And then for our aggregate expenditures model, we put those 2 things together. So you can see it shifts this sloped line up by $300 at every point. So here, when we go to 500, now we're at $700 of spending, right? 400 plus 300. Or if we were at $1,000, now we get $1,100 in consumption. So any sort of autonomous expenditures that, like a horizontal line, means it's not affected with the level of GDP. It doesn't change at all as GDP goes up and down. Induced expenditures is that upward sloping line, meaning it is changing with the level of GDP. So we're going to have some sort of equation or some sort of function of real GDP. So in this case, this line is represented by the function of C, consumption, is equal to 300, so that's this autonomous part, plus 0.8 disposable income, or 0.8y, and then that gives you the upward sloped line. So investment is also something that is really important to our aggregate expenditures model, and partly because investment includes something called inventory. So a business inventory is when they produce items that they would like to have on the shelves that they don't necessarily expect to sell in the immediate period. So you go to the grocery store and you want to buy a box of crackers, you find the cracker aisle, and you just pick a box off the shelf. And usually there's lots and lots of boxes. It goes back. You taking one box off the shelf doesn't really affect anything. Another customer comes in and takes another box off the shelf. And so businesses have what's called planned inventories. Okay, so they may, maybe you have a shirt factory or a shirt, not a factory. what's a word for a store? You have a shirt store. Okay. So you have a shirt store and you want to have 10 shirts on the racks at all times. Okay. Because you want your customers to walk in and feel like they have options and you don't want it to look empty. So you plan to have 10 shirts in inventory. And you also plan to have 20 shirts that you think you're going to sell this month. And so you're going to produce a total of 30 shirts. And this includes the 20 you think you're going to sell, plus your planned inventory. Now, sometimes what happens is businesses don't anticipate correctly. So I think I'm going to sell 20 shirts this month, but maybe I actually sell 25. So even though I had a planned inventory of 10, I actually sold 5 of those, which means I have an unplanned decrease in my inventory. My inventory actually dropped by 5. And that's because I was wrong, right? I thought that I was going to have 20 customers and I had 25. And so inventory is also important because it allows businesses to be flexible as demand is changing. Or that way, if they're incorrect about how many customers are going to show up, they are available to sell a little bit extra. So we've got planned investment. And in this case, our planned investment is going to be inventory. How much inventory our business decided they wanted to make. And then unplanned changes in inventory is when they sell more or less than they expected. So this actual aggregate expenditure number is greater, is higher, or lower than what they expected. So decrease in inventory means that our aggregate expenditure is greater than our real GDP. So in this case, aggregate expenditure is how much stuff people bought. And real GDP down at the bottom is going to be how much stuff was produced. Or disposable income, if you're using income approach versus expenditure approach. When this happens, it signals to businesses that they need to produce more. So I want to have 10 shirts in inventory. If I only have 5, what I'm going to do next month is I'm going to produce more. So I'm going to produce an extra 5, right? Because I actually need 10 shirts in inventory, and then I need 25 to sell. So I really need to be producing 35 shirts. And so I'm going to produce that extra 5 so that I hit my inventory mark. So I'm going to increase production in the next period. I'm also going to hire more people because I'm selling more shirts. I may need more hours or more workers. I also need to have more people working just to produce that change, that extra inventory. If we have an increase in inventory, this means that we didn't sell as much as we planned. So I thought I was going to have 20 customers and I actually only had 18. So my unplanned inventory increased by 2. Okay, so it increased. I have 12 shirts in inventory instead of 10. So this is when your aggregate expenditure is less than your real GDP. So spending is less than production. This signals to the businesses that they overproduced. So next time, I'm going to make even less. So if I think I'm going to have 18 customers next month, I'm going to produce only 16 shirts because I have this 2 extra left over from last time. So I'm going to produce even less. So I'm going to produce 16 instead of 20, and that's going to reduce employment and it's going to reduce production. We can also see that on our graph. So here we have this 45-degree line, this black line here. This is a reference point. This because it's 45 degrees, that means that this shows you all of the points where aggregate expenditures are equal to real GDP. And so anytime our green line or our aggregate expenditure line crosses that 45-degree line, that's going to tell you the point on that curve where our economy is in an equilibrium, where aggregate expenditure is equaling real GDP. So here, this is going to be at 7,000 on this graph. And we get $7,000 worth of stuff that's produced and $7,000 worth of stuff that's purchased. If we're at points, let's just draw this vertical line here at our equilibrium. Everything over here on the left-hand side is going to be points where our expenditures, our aggregate expenditures, are greater than our real GDP. So spending is higher than production. So any points on our green line to the left of that equilibrium are going to be points where our businesses undercalculated how many customers they were going to have. They're selling 25 shirts when they thought they were going to sell 20. And so they're going to see a drop in their unplanned inventories, right? Decrease. They wanted 10 shirts, now they only have 5 left. They need to increase production. Anything to the right of this line, or to the right of that equilibrium, so this portion of that green line here, this is where we have overproduced. We've made too much stuff. Our aggregate expenditures is going to be less than real GDP. Okay, so spending is less than production. Okay, so over here our businesses guessed wrong, right? They overproduced, and customers just didn't buy as much. This anywhere over here means that in our next period, they're going to reduce production, reduce employment until they get back to that equilibrium point. So the equilibrium in my example up here would be I have 10 shirts in inventory. I produce 20 shirts to sell this month, and I have 20 customers show up. That's going to be at this big red dot here, where our consumption. So we don't necessarily need that 45-degree line. It's not crucial. It's just a reference point to help us have an easier time finding where our market is going to be in an equilibrium. For instance, if we say, autonomous investment decreases, it's going to shift that line down. Now we can see it crosses over here. That's going to be our new equilibrium point, where aggregate expenditure is equal to real GDP. So it's just a helpful tool for us in finding that equilibrium point. And anything that's not an equilibrium is a signal to businesses that they need to change their level of production. Produce more, produce less until the economy is in that equilibrium.